Welcome to the DIY Honda Garage channel. DTC P0192 indicates that the fuel rail pressure sensor circuit voltage is lower than expected, prompting the powertrain control module, PCM, to register a fault. The fuel rail pressure sensor plays a crucial role in monitoring the fuel pressure within the fuel rail, ensuring that the engine receives the necessary fuel for optimal performance. It is typically integrated with the fuel rail, which is positioned near the engine, allowing it to accurately gauge the fuel pressure. The PCM uses data from this sensor to adjust fuel injector timing and fuel delivery, making it pivotal for engine efficiency. This DTC helps diagnose potential issues within the fuel system and indicates that further investigation is necessary to ensure proper engine operation. Accurate diagnostics will require access to Honda's diagnostic tools and an understanding of the surrounding circuitry. The error, P0192, corresponds to a low-voltage signal detected from the fuel rail pressure sensor. This sensor, a vital component, provides real-time readings of the fuel pressure in the rail, which is essential for maintaining optimal engine performance. Located on the fuel rail, it connects directly to the PCM, allowing for seamless communication of fuel pressure data. A significant drop in the sensor's output voltage indicates that the PCM is not receiving accurate information, possibly due to a failure within the sensor itself or an issue with the associated wiring or connectors. In this context, a low-voltage signal could compromise the fuel delivery process, leading to poor engine performance or higher emissions. Addressing this diagnostic trouble code is crucial to ensure the vehicle operates smoothly and efficiently. The possible causes of DTC P0192 can broadly include a faulty fuel rail pressure sensor, wiring problems, and potential PCM malfunction. A defective sensor may not be able to provide accurate voltage readings, thus triggering this DTC. Additionally, damaged or corroded wiring, including connectors that are worn or improperly seated, can disrupt the signal transmitted between the sensor and the PCM. Furthermore, while less common, a malfunction in the PCM could also lead to incorrect voltage readings being interpreted as low signal output from the fuel pressure sensor. Careful visual inspections and tests are imperative for isolating and identifying the exact source of the issue, as each component plays a critical role in the overall functionality of the fuel management system. The symptoms associated with DTC P0192 may include rough engine performance, frequent stalling, and illumination of the check engine light on the dashboard. An inconsistent fuel supply, owing to inaccurate pressure readings, may cause the engine to run unevenly or fail to start altogether. In cases of significant voltage drops, the PCM may resort to a limp mode to protect the engine, resulting in reduced power output and overall performance. Additionally, drivers may experience difficulty during acceleration or poor fuel efficiency as the engine struggles to maintain the correct air-fuel mixture. Recognizing these symptoms early is crucial in preventing more extensive damage to the fuel system or engine over time. In the first troubleshooting step for DTC P0192, the technician must turn the vehicle to on mode and wait for 2 seconds. This initial action ensures that the onboard diagnostic system has time to initialize and communicate with various sensors, including the fuel rail pressure sensor integrated with the fuel rail. During this time, the technician can observe the data provided by the Honda Diagnostic System, HDS, to check the fuel pressure converted from PF sensor voltage value. If this observed value is less than 0.31 volts, it confirms the presence of a fault, effectively duplicating the failure condition noted by the DTC. It is essential to accurately measure this voltage level, as it can provide immediate insights into the health of the fuel rail pressure sensor and its circuit. For the second troubleshooting step, the technician should begin by disconnecting the fuel rail pressure sensor connector, which typically comprises 3 pins. This allows for a clear inspection of the sensor's wiring and connection points. Next, with the ignition in the on mode, the technician should measure the output voltage at the disconnected sensor connector. Under normal circumstances, the measurement should read approximately 5.0 volts, indicating a solid connection and proper voltage supply to the sensor. If the output deviates significantly from this value, it suggests that there may be a failure in the sensor itself or the related circuits, necessitating further investigation into the wiring or the powertrain control module, PCM. Precise voltage measurements are integral to diagnosing the underlying issue without unnecessary component replacements. In the third troubleshooting step, the technician must disconnect both the fuel rail pressure sensor connector and the PCM connector to thoroughly inspect the related circuits. This step includes checking the VCC1 power supply circuit and the Kiev signal circuit for any abnormalities. Using a multimeter, the technician will conduct an open wire inspection by measuring resistance in the VCC1 circuit, which should ideally show less than 1 ohm in normal conditions. Additionally, the signal circuit, PF, must be open to ground, which should yield a reading of more than 1 megaohm. These measurements are critical. If the readings are outside the expected range, they indicate problems in the circuits that could lead to erroneous signals reaching the PCM. The integrity of these wiring paths is vital for the successful operation of the fuel rail pressure sensor. In the fourth troubleshooting step, after confirming that the fuel rail pressure sensor and its connections are functioning correctly, the technician should shift focus to the PCM itself. If both previously tested components return normal readings, it is now open to consider the PCM as the source of the problem. The PCM, or Powertrain Control Module, is essential for interpreting the sensor input and adjusting fuel delivery accordingly. Any malfunction in this component could lead to a variety of issues, including the DTC P0192. It's crucial to perform a thorough examination of the PCM connections and to ensure that its firmware is up to date. If a fault is confirmed in the PCM, further steps may involve reprogramming or replacement of the module, depending on the underlying cause of the failure. After successfully diagnosing and addressing the issues related to DTC P0192, it is imperative to perform a final repair verification to ensure that the problem is resolved. This process begins with reconnecting the fuel rail pressure sensor and PCM connectors. Following reconnection, the technician should use the Honda Diagnostic System, HDS, to clear any stored DTCs from the vehicle's system memory. After clearing the codes, a comprehensive test drive is necessary to confirm that the fuel rail pressure sensor is operating within normal parameters. During this test, monitoring the fuel pressure data will further validate that the repairs have been successfully implemented and that the vehicle is functioning properly. Conducting these verification steps is essential in ensuring that no residual issues remain. Preventive maintenance is crucial in reducing the likelihood of encountering DTC P0192 in the future. It is advisable to regularly inspect the wiring related to the fuel rail pressure sensor for any signs of wear, damage, or corrosion. Ensuring that connectors remain clean and securely fastened can prevent potential connection issues that may lead to low voltage readings. Furthermore, performing periodic diagnostic checks with the HDS will allow technicians to stay ahead of any emerging issues and address them before they escalate into more severe problems. A proactive maintenance strategy can significantly minimize the risks associated with fuel system failures and prolong the overall reliability of the vehicle. In summary, DTC P0192 alerts Honda Accord owners and technicians to a low-voltage signal from the fuel rail pressure sensor, highlighting the need for immediate investigation. Proper diagnostics involve systematic checking of the sensor, wiring, and the PCM to accurately identify the cause of the low-voltage indication. Understanding the roles of each component involved is critical, as is the collection of accurate voltage measurements to diagnose issues more effectively. Once repairs are made, final verification steps are necessary to ensure correct functionality. Additionally, adopting a preventive maintenance approach helps mitigate the risk of similar issues occurring in the future, safeguarding engine performance and reliability. Please like and subscribe to the channel. See you next time.